Good afternoon and welcome to Webinar Wednesday. We're excited to have over 200 registered attendees for today's webinar, which is eligible for 1 credit from the ACI. Let's get started by giving one of the lucky attendees an ice blanket for answering this trivia question. Today's sponsor, Universal Medical, is headquartered in Missouri. Name one of the national baseball teams that are located there. Answer now using the question feature on your dashboard. While you're answering, I want to invite everyone to join us at the MD Expo Irvine Conference, which will bring HTM professionals from across the nation to Irvine, California for 3 days of learning, networking, and the latest advances in technology, products, and services. Registration is now open. The MD Expo will be from April 9th to April 11th, and you can receive complimentary admission by using the VIP pass, Compliments of UMRI, which is found in the Webinar Wednesday workbook. If you did not receive this workbook earlier today via email, you can download one now in the handout section of your dashboard. Details for the conference can be found at mdexposhow.com. And the winner of our ice blanket is William Tahite. The correct answer was St. Louis Cardinals or Kansas City Royals. Webinar Wednesday would like to thank our sponsor, Universal Medical, which has nurtured a business philosophy founded on offering comprehensive nuclear medicine equipment services at a reduced price. Universal Medical's products and services include new and reconditioned nuclear imaging systems, quality parts, excellent equipment service, training courses for healthcare technology managers, camera system moves, technical and clinical support, flexible financing options, and more. Visit uni-med.com for more information on this company. Our presenter today will be Craig Diener, Senior Product Manager at Universal Medical, who will be joined by a special guest, Jackie Minks, Director of Radiology at Martin Center Cox Health. Craig, you may begin whenever you are ready.
Thank you, Jamie. And welcome everyone to our webinar today on procuring your perfect SPECT camera. Today we'll be talking about the following points: which camera works best for your specific needs, notable camera features and differentiators, budget factors, facility requirements, and then we'll have time for some questions at the conclusion of the presentation. So the problem statement for today is you need to acquire a replacement SPECT camera or add another to your department. So where do you start? There's so many factors to consider, including specific applications and features that are important to your staff, which cameras can handle your patient load, budgeting and financing, and will the camera fit in the allotted space that you've assigned to it. Let's start by looking at the 3 main types of cameras. There's the general purpose camera, the dedicated cardiac camera, and the portable camera. The general purpose nuclear medicine camera is the workhorse of any nuclear medicine department. These cameras will perform all studies, including oncology studies, neurology, cardiology, renal, pulmonary, and much, much more. These studies are accomplished by positioning the detectors into the optimal angle or position for the appropriate study. For example, 90 degrees for cardiac studies, 180 degrees for whole body studies, and various other positions for upright imaging, chairside imaging, stretcher, and extremity imaging as well. Characteristics of the general nuclear camera include a large field of view for maximum coverage of the body. Because of the large detectors, the system is also quite large and requires a large scanning room as well. Some additional features I want to mention about SPECT cameras are attenuation correction. Attenuation correction is a method of correcting for artifacts caused by body tissue and other organs than the one of interest. There are 2 methods of attenuation correction: line source and CT. The line source includes housings that are mounted to each detector. The housings contain a line source of gadolinium, germanium, or some other radioactive source. As the system is acquiring a SPECT study, the housing will open at the correct position, providing transmission data simultaneously with the collection of emission data. The resulting transmission map is used to correct the emission data. One drawback to line source attenuation is the cost to replace these sources, typically on an annual basis. CT attenuation correction and mapping is accomplished with a CT tube and a detector attached to the gantry. In many cases, a full diagnostic CT is incorporated into the gantry. The system can then be used as a standalone CT when not in use as a SPECT system. These systems carry a much larger price tag than a SPECT-only camera. With the push for low dose and low exposure in the industry, half-time imaging is becoming more common in the market. Half-time imaging is a reconstruction algorithm that allows you to acquire a study in half the time or half the dose. Some examples of half-time imaging is Philips Astonish, Siemens Flash 3D, GE Evolution, and the Segami ClearSpeed. This is especially important for departments with heavy patient loads. Automatic body contouring is a feature that keeps the detectors as close to the body as possible. The closer the detectors to the body, the better the image quality. Most cameras include auto body contouring as a standard feature these days. Collimator selection is important, especially on general nuclear cameras. Be sure to purchase the appropriate collimators for the studies you'll be doing. Low energy high-res collimators, typically for cardiac imaging, and many others. High energy collimators for iodine and other high energy isotopes, and pinhole collimators for thyroids. Other collimator types include medium energy general purpose, low energy general purpose, and different manufacturers have other selections as well. So let's look at some examples of general purpose cameras. The Philips Brightview is an open gantry type system with a jumbo field of view for maximum body coverage. The Brightview incorporates Bodyguard, Philips automatic body contouring feature for close-up imaging. The touchscreen acquisition allows for quick setup of studies. The patient table is tethered to the gantry and can be undocked and moved away for stretcher imaging. Although the Jetstream and EBW workstations were standard with the Brightview, it can be integrated to other manufacturers' workstations as well. Astonish reconstruction allows for reduced acquisition time or dose, and CT capability is available on the Brightview XCT system. The Symbia system. Symbia is another example of an open gantry with a large field of view detectors. As with the Brightview, patient table can be undocked and moved away for stretcher or chairside imaging. Symbia also is available in a SPECT CT version known as the Symbia T. Like the Brightview and Symbia, the GE Infinia has a large field of view and is capable of SPECT, whole body, and planar imaging. Auto body contouring is standard on the Infinia as well. Slip ring technology allows for continuous rotation without the worry of gantry cable that needs to be unwound after each tomo study and from potential damage from stretching the cable. CT capability is available on the Infinia Hawkeye systems as well. And one more real quick. The Millennium MG from GE is a smaller variable angle camera. Because of the small footprint, it'll fit in many rooms that the Brightview, Symbia, and Infinia will not fit into. It features a full field of view detector, or two detectors, excuse me. However, the MG does not have the capability to do stretcher imaging. And the DDD Quantum PM, which has the smallest footprint in the industry for a general purpose camera. The detectors are slightly smaller than most general purpose cameras, yet big enough to scan large patients. Its simplistic design provides for easy setup and patient positioning, and auto body contouring is standard with the Quantum Cam. The Quantum Cam can be integrated to almost any workstation on the market. So let's look at cardiology cameras. Most manufacturers offer a dedicated cardiac camera. These are usually compact cameras with dual detectors fixed at a 90-degree angle for optimized cardiac imaging. Some manufacturers offer a patient bed that provides for supine and prone imaging. This is the traditional way of imaging the heart. However, there's more upright imaging cameras available on the market now than there ever was before. Upright imaging provides a less challenging way for patients to be imaged. Supine imaging requires a patient to climb onto and position themselves on a narrow patient table. Once they are on the table, they must raise their arms over their head, which can be uncomfortable. Upright imaging can be a good solution for these types of patients. So as with the variable angle cameras, cardiac cameras offer additional features such as attenuation correction, half-time imaging, and a multitude of workstation and software applications. So let's look at some cardiac camera examples. The DDD Core Cam, formerly known as the Cardio MD, is a compact cardiac camera. The Core Cam and the Cardio MD are the most successful and proven cardiac cameras in the history of nuclear cardiology, with almost 2,000 units installed worldwide. It is capable of supine and prone imaging and will integrate to most any workstation and PACS system on the market. The Core Cam has a very small footprint and can be installed in just a few days, allowing for installation and applications within a 1-week time frame. The Siemens C-Cam is similar to the Core Cam, with the exception of the reclining chair. This makes for easy patient loading and unloading, and the small footprint again allows for minimal room size and can be installed in just a few days. Spectrum Dynamics has been an innovator with the introduction of the D-SPECT cardiac camera. The D-SPECT incorporates a chair for flexible patient scanning, whether upright or prone. The CZT detector technology provides the fastest acquisition capability in the market, typically about 2 minutes. This feature is geared towards sites with high patient volume. Although Spectrum Dynamics has led the way, there are other CZT systems available on the market. For example, the GE NM530 is another good example. And although portable cameras do not have SPECT capability, it's worth mentioning how they can benefit your nuclear department. If you have a large patient load, it may not make sense to use your workhorse general purpose camera for spot studies, thyroids, and small organ procedures that could be done on, say, a single head camera. A portable camera could free up your department for your bread and butter studies like cardiac and bone specs. The portable camera usually has a small field of view, is a self-contained unit that can be moved throughout your facility to do bedside imaging, brain deaths, and other studies. You may find that a new SPECT camera is not needed if a lower cost portable camera can fill your needs. And then workstations. Let's talk workstations for a little bit. One of the most important aspects of your purchase is what type of workstation you'll be purchasing with the camera. Most vendors offer a workstation with their camera. However, you may wish to keep your current workstation with the camera that you'll be purchasing. Check with your vendor for compatibility with your new camera, and of course with your IT department on the operating system compliance. There's been a big push towards getting away from Windows XP and older versions of operating systems and going to at least the Windows 7 platform. There are many OEM and independent workstations available. Most now are PC-based with a Windows platform. There's 3 main cardiac programs on the market: Cedars, 4DM SPECT, and Emory Cardiac Toolbox. There's also specialized applications for almost any type of study. These can include fusion imaging software, neurology software, and a host of others. So be sure to sit down with your staff and discuss all of their software needs. In addition to the camera workstation, you may find that an additional workstation or a review station is needed in a separate reading room, facility, or even a physician's residence. All of these options are available either as a physical workstation or a virtual workstation with the use of concurrent licenses. So, if all cameras have the same functionality, which most do, how do you choose the best one for your facility? Consult your staff. They may have had experience with several vendors, both good and bad, in years past. There may be specific options or features they prefer or require. They may prefer to use a camera or a workstation platform they're familiar with. They may have a good relationship with a certain service rep. The type of camera, number of cameras, and variety of cameras you purchase should be based on your patient load, patient study type, and the allotted space, as well as your budget. Some companies offer complete nuclear medicine consulting services, such as this, to assist you with your decision. For the next few slides, I'd like to introduce Jackie Minks with Cox Health in Springfield, Missouri. Jackie has recently gone through the procurement process at one of the Cox facilities and has agreed to share her experiences in preparing for the purchase of several new cameras in her department. Jackie?
Thank you, Craig. Thank you for having me speak here today with you all. So I first wanted to tell you a little bit about Cox Health, where I work. Cox Health is established in 1906 and is a community-based hospital here based out of Springfield, Missouri. Our system is comprised of 5 hospitals, 2 being in Branson and Monette, Missouri, and we have over 80 physician clinics. Within our system, we also offer walk-in clinics, urgent care sites. We are comprised of 4 emergency room departments and 1 being a level 1 trauma center here in Springfield, Missouri. We also have several centers of excellence here in neurology, oncology, cardiac and vascular services, and orthopedics. We employ 10,000 people and have a physician staff of 600 plus providers. So your organization size and process may vary, of course, with regards to how you go about your decision with regards to nuclear cameras. But I wanted to share with you some of the processes that we use here at Cox Health in evaluating capital equipment purchases for the future. So the first thing that I wanted to talk about was how we go about our purchase, in that we take a very system-wide approach. We look at all of our nuclear med departments within Cox Health at each location to get a very global view of our service line. We like to evaluate what procedures are done at each location, the volume of each one of those procedures. We like to evaluate the backlog that is currently in place at each location to see where we have additional demands and where we need to grow that service line. We also like to evaluate the utilization of each camera at the site and make sure that we're not in a situation where we have underutilized equipment. We look at our outpatient facilities versus our inpatient facilities and the types of volumes of nuc med studies are done in those locations. After we've done that, we will look at possibly replacing an existing equipment, a camera. What we do when we do that is we look at the capabilities and what do we need in order to meet our current demands related to the types of exams and volumes that we're currently doing at each location. We also look at the possibilities of any additional exams that we may need to offer with a new camera that we're currently not able to do. We take on looking at cameras that could possibly be moved from one location to another to ensure that we are utilizing all of our cameras. For instance, we had a SPECT camera in our hospital system that was underutilized but very old and needed to be replaced. This was our most recent procurement. What we did was we replaced that system in a different location for outpatient type exams, and in the hospital actually went with a cardiac camera instead. So again, we kind of take a very global approach at all our departments to make sure that the cameras are placed appropriately within our organization. Once we have made the decision to purchase a new camera, here are some of the steps that we go about in evaluating the camera and what we consider. Obviously, we're going to look at capabilities, look at any new advancements or technologies that are being offered that would enhance our current service line. We look at a system performance and, really importantly, the technologist's ease of use. We look at system reliability, downtime, and patient comfort with our bariatric patients. I think we all struggle with that, and it presents a challenge in with many of our cameras. We look at image quality, again, on all types of patients and all exams. We look at our service quality and the timeliness of response for any downtime. We look at the cost of service. One thing we also consider when we think of service, we also look at, does the vendor offer an opportunity to train our biomed folks so that we can lower this cost of service? We look at the cost of equipment, cost of construction, and budget factors. We look at the installation challenges, if they exist. We look at the amount of time that will be down in the department during installation. And then, of course, we look at our room constraints, which I think that Craig will go into further detail on that later. After we've done that, we will decide which vendors that we want to meet with, and we will plan for site visits. We will take a nuclear med tech, supervisor, director of radiology, and of course we'd love to get a hold of our radiologists if we can get them to come. We like to ensure that the technologist during that visit has some real hands-on experience with the system, with another technologist, and we also like to do this without the vendor present so that we can really get some good and open, honest feedback. We work real hard to work with our supervisors and providers and directors at these other locations and get feedback on service, budgetary issues, quality, image quality issues as well. Finally, what we'll do when we narrow our options down is we'll take time to do an analysis of the market trends with that particular product. We use an independent company, much like an MD byline, that helps us. But we look for things like recall issues from the FDCA. We look at clinical studies that maybe have been done using that particular equipment to help us with any new advancement options. We also like to trend end user feedback and see how that vendor service and response has been. We also like to evaluate if this piece of equipment that we're looking at has advancement, or is it becoming, is that particular product maybe becoming a little bit more obsolete? Is it upgradable? And then, of course, we look for reimbursement trends to work through our ROI. Obviously, when we consider costs, we also always try to explore options to consolidate equipment with other imaging equipment within our radiology department to help us control costs. So at this time, I'd like to turn it back over to Craig. I think he is going to elaborate a little bit more on some of the items that I've touched base on.
Well, thank you, Jackie, and you've definitely done a thorough job and pointed out a few things as well that I was not able to cover. But let's move on to budgetary needs. In conjunction with deciding on your new camera, you'll need to consider the financial implications involved. Do you plan to purchase or lease the system? Many facilities do not consider the depreciation factor when purchasing or leasing equipment. Because of the new camera introductions and evolving technology, the value of the equipment is a fraction of the original purchase price, and sometimes zero once the lease period is up. I don't know if any of you have ever encountered that, but because of the fast pace of technology, that drives older equipment value down. So something to consider is a program that will allow you to pay a monthly amount that will provide you with a camera and service with no time commitment. The SPECT program, for example, at Universal does exactly that. It provides you with a camera without an investment in capital equipment or lengthy service contracts. Finally, and most importantly, will the camera fit in your facility? Well, it's best to do a site survey before you make your decision. Measure the doorways, the hallways, the turn radius in the hallways, and the elevator doors. Check the elevator capacity to make sure it'll hold a heavy piece of equipment. If you currently have a camera, how did they bring that camera in? Was it hoisted through a window or an elevator shaft, or was it just brought right through the doors? Sometimes an elevator company can assist with allowing access to the elevator shaft or temporarily adjust the elevator for a heavy capacity short term. If riggers are needed to get the old system out and the new system in it, it is best to coordinate this with the riggers, the new camera provider, and the old camera deinstaller. Also, check if a street closure permit will be needed for the installation. Measure each wall in the scanning room as well as doors and any other space in between. Other factors include hot lab placement and access, treadmill placement, extra collimator and carts, and workstation placement. All of these have an impact on the fit and placement of your camera. It's also important to check with your facility manager on floor loading. Placing a 2 to 3 ton camera on a concrete floor above ground can be a little tricky. Be sure you know where the floor joists are located. Some cameras require anchoring through the floor if the concrete is not thick enough. And speaking of anchoring, if you're in California, you'll need to work with the state on seismic anchoring procedures, or OSHPD as it is known. Check with your facilities manager. If you need to do electrical upgrades, some larger cameras do use 208 volts or 480 volts, especially on the SPECT CT systems. So have as much of this information ready before making your final decision so you can work with the vendor's project manager for a smooth installation. So in conclusion, procuring a SPECT camera is not a simple task, but it does not have to be scary either. Consider all of the factors, work with your department team and partners, and the best choice will present itself. So thank you very much, and I'll open it up to questions if there are any.
Hi Craig, this is Jamie, and we have received quite a few questions from attendees during the presentation, but I'd like to remind everyone you can submit questions at any time using the question feature on your dashboard. But Craig, the first question, out of the cameras you reviewed today, are there any major drawbacks to be aware of?
I wouldn't say any major drawbacks. You know, every OEM does have their own way of doing things, and they do have their cameras are all, you know, they're all within a certain specification. I wouldn't say there's drawbacks or necessarily limitations, but one thing I did mention an example of is the Millennium MG, which does not do stretcher imaging, for example. If you do not do stretcher imaging, that's not a problem. It'll do all the other studies. But if you do need to do stretcher imaging, you may want to make sure you have a camera that will be able to accomplish that.
All right, next question. Is there a particular general purpose camera that does cardiology studies better than others?
Well, that's a good question. And everyone has their opinions. And, you know, when you go to the different OEMs, Philips, Siemens, GE, DDD, Spectrum Dynamics, all of these companies, they all do produce a good product. My suggestion would be, if you know somebody at a facility that uses a camera that you're thinking about purchasing, to go there and look at images that they've done and compare them to what you're using right now or what you want to be looking at. It's always good to get another outside view of the particular camera you're looking at. And it doesn't hurt to go to multiple facilities as well and look at the different products. Some people may have Philips, some people may have GE, some may have Siemens in the different facilities. It's always good to look at those.
You mentioned halftime imaging. Do you know which camera supports that feature?
Pretty much all cameras these days offer some type of halftime imaging. Where you might have some issues is on some of the older cameras, but there are some aftermarket options available. UltraSpect in particular does offer halftime imaging that will work on some of the older equipment, but pretty much all new cameras will have some type of halftime option.
Here's a great question about the industry. This attendee says, the industry seems to be moving towards SPECT CT. Will there come a time when SPECT-only cameras will become obsolete?
Yeah, that's another good question. The market is definitely trending towards SPECT CT, and I believe there will come a day when most hospitals will have only SPECT CT, but there will always be a need for a SPECT-only camera in some form or another. And as I've mentioned before, if nothing else, as an overflow camera to use for certain studies, while your SPECT CT camera is being used for some of the bread and butter type studies. So I don't think SPECT alone is going to go away.
Here's another attendee question. How many types of collimators would a facility typically have at a time?
You know, and that's a good question too, depending on the studies they're doing. Typically 3 to 4 sets per system. Some customers only need 2 sets. It just depends on the studies they're doing. If they're doing a lot of different types, including thyroid studies, obviously a pinhole would be needed. Keep in mind too that you may only have room for so many collimators in your department. These days, collimators are stored on a cart, and you may only have room for a certain amount of carts as well as collimators. One way to remedy that, of course, is to have a separate room or closet to be able to store them. Some cameras have a semi-automatic collimator cabinet, but there's limitations there too. Typically, they only store 4 sets of collimators at a time. But yes, typically 2, 3, 4 sets of collimators is what we see in the market.
Perfect. Another question is, do these systems have a means of recording patient radiation dose?
Not that I'm aware of. And Jackie, I don't know if you can help me with that one or not. I'm not an actual user. But patient data is definitely stored and should be kept by the hospital for a certain period of years. They should check with their HIPAA criteria and see what that storage time frame should be in case it's ever needed and they need to refer back to it.
All right, Craig, thank you for your time today, and Jackie, thank you for your time and wisdom as well. And thank you to our sponsor today, Universal Medical. One lucky attendee will win an Amazon gift card for completing the post-webinar survey, which will appear on your screen shortly once we close out the software. Do not disconnect. You must complete the survey to obtain your certificate of attendance. If you do not see the survey, please email us at webinar@mdpublishing.com. You can find a complete list of upcoming webinars at technation.com/webinars. See you next week.